Welcome to a lesson with Dr. Powell. Let's take a look at how we can count the number of different configurations we could have of some beads on the corners of a cube if all the beads are distinct. Okay, so there's 8 different corners. That can be 8 different beads. Alright, and we think the different permutations that we could make on these different corners. We could think of that as S8, so permutation group on 8 things. And let's think about how we can keep the exact same configuration. Like, what is a subgroup of S8 that keeps us kind of with the same configuration when we can rotate this cube and think of that as being like the same configuration. It's kind of the 3-dimensional rotation here into symmetrically, so it looks the same after we've rotated it, just the beads have been put into different places because of the rotation. Well, S8 actually acts transitively on such configurations, and so we can think about a stabilizer subgroup of a configuration, and then its cosets are in 1-to-1 correspondence with the number of configurations that we can have, and that's because S8 acts transitively here on the collection of configurations. Now, how do we think about the stabilizer subgroup? Well, if we think about each edge as being like, being an arrow this way and an arrow that way, then really what we have is, if we start with a direction this way, a symmetry or a rotation would be taking a beginning arrow and just putting it in line with any one of the directed arrows. That actually determines a rotation uniquely, and all of them can be described that way. So, if you think about it, there are 12 different edges, so there's 24 different arrows. And so there's basically, if we choose one of them and see where it's going to go, there's 24 places it can go, including itself. So there's 24 different rotational symmetries. So the stabilizer subgroup has size 24. So if we take 8 factorial divided by 24, we should get the number of cosets, the number of configurations. So in making that calculation, we have 8 times 7 times 6, okay, times 5 times 4 times 3 times 2 times 1. And if we divide it by 24, notice that this part's 24. So we end up just getting this calculation right here. This is 30 and 56. So that's what 100. So that's like 150, 18, 160, 168, 0. Ooh, okay. So there's 1,680 different beaded cubes we could have configurations if all of these beads are unique and different. Thanks for watching.